SETI's hunt for alien life, exploring uncharted frequencies. Imagine a search that spans over 1,300 galaxies, diving deep into unexplored radio frequencies in the quest for extraterrestrial signals. That's exactly what researchers Chenoa Tremblay and Stephen Tingay have embarked on with the Murchison Wide Field Array, MWA, in Australia. Unlike traditional SETI searches that focus on higher frequencies, this study explored low radio frequencies between 80 to 300 megahertz, a range mostly untouched in the search for alien life. The idea is simple. The lower frequency range might hold secrets that higher frequencies don't reveal. Why not expand our search criteria to make sure we aren't missing something? Tremblay and Tingay zoomed in on a specific patch of the sky in the constellation of Vela, focusing on galaxies whose distances were already well measured. This targeted approach allowed them to estimate the power needed for a potential alien transmitter to send a signal our way. The result? No signs of alien life. But don't be disheartened. These findings aren't a dead end. Instead, they help fine-tune our expectations. For instance, it's estimated that a transmitter would need to output around 7 by 10 to 22 watts at 100 megahertz for us to detect it. That's an immense amount of energy. For comparison, a Type 2 civilization on the Kardashev scale would need the energy of an entire star to reach such power levels. But what if the signals are out there, just not in the form we expect? What if these advanced civilizations, if they exist, are using different methods, like lasers, or communicating at higher frequencies? Or maybe their radio beacons were temporarily turned off, or pointed elsewhere when we were listening. There have been other searches as well. The Glimpsing Heat from Alien Technologies project used NASA's Wide Field Infrared Survey Telescope, WISE, to look for civilizations that might have constructed megastructures, like Dyson swarms, around stars. But again, nothing was found. Michael Garrett and Andrew Simeon's search of background galaxies also helped place limits on how powerful a detectable signal would need to be, refining our understanding of where to look next. What's clear is that our current technology and search strategies are just scratching the surface. There are potentially trillions of galaxies in the observable universe, and we've only examined a tiny fraction. As Tremblay and Tingay point out, several powerful radio emitters on Earth operate at these lower frequencies. So it's possible that similar signals could exist elsewhere in the cosmos. The road ahead for SETI involves expanding our search across multiple frequencies and approaches. It's not just about looking at the skies. It's about listening in new ways, being open to the unexpected, and pushing the boundaries of what we know. SETI's journey continues. Stay tuned. With a call to action, subscribe for more updates on the quest for extraterrestrial life.